review some stuff that we talked about on Monday's class and to get you ready for class on Wednesday. So you can watch this either as a review once we've covered the material, or you can just kind of use this to get ahead and figure out what we're going to be doing tomorrow. So remember last day we started talking about solving for x, where x is an angle. So we don't know what the angle is here for x. Remember the first thing that we had to do was use our cast rule to figure out in which quadrants is this sine value equal to a positive 1/2. So we knew that there was going to be a positive value in the sine quadrant and a positive value in the all quadrant. So that's the first little bit we should know. The second bit was talking about our special triangles where we had pi over 3 and pi over 6, root 3, 2, and 1. We could also use our second special triangle with the root 2, 1, and 1 with the pi over 4s involved inside there. What we have to recognize is that we have a 1 and we have a 2. So where do we see the 1 and the 2 over in our special triangles? Well, we'd have to figure out that it's going to be this 1 and this 2. So those numbers are available here, but not on this triangle. So then we'll identify which angle should we use as our reference. Because it's 1 over 2, that means in its sine, it's going to be the opposite over the hypotenuse. So the opposite of this angle here, pi over 6, will be 1, and the hypotenuse is 2. So we're going to use a reference of pi over 6 here. Step 3, I'll do it over here. Step 3 was talking about where our reference can be used to get some different answers. So we'll have reference in there, pi minus your reference in the top left, pi plus your reference in the bottom left, and 2 pi minus your reference in the bottom right. So because we realized that in the top 2 quadrants, one of our answers, right? So if I just put a 1 right here, one answer is just going to be our reference. So one answer is pi over 6 is equal to x. Again, we need to figure out what the second answer should be. So the second answer can reside in this quadrant up here. And we have to actually do pi minus our reference. So that would be pi minus pi over 6 is equal to x. One cool thing that we can see when we have pi is we can change the denominator by multiplying the top and the bottom by 6. So here we'll have 6 pi over 6 minus pi over 6 is equal to x, and 5 pi over 6 is equal to x total. So this is answer number 1, and this is answer number 2. So we have 2 options here on the unit circle where sine of an angle will equal 1/2. That means that sine of pi over 6 will equal 1/2, and sine of 5 pi over 6 will also equal 1/2. So that's a bit of review from last day. Now we'll get into adding a little bit of algebra. So whenever we have a coefficient in front, and I'll clarify this by showing that it's multiplied, we need to be able to get sine or cos or tan all by itself. So in order to do this, we'd have to divide both sides by 2. So this is just a regular old algebra technique that hopefully you guys should be pretty comfortable with. So because that the 2's will cancel now at this point, our sine x will be equal to 1/2. And this is the exact same question as the previous question. I just wanted to clarify that we need to do a little bit of tidying up, so we had to get rid of that 2 in front in order to solve for that x. So if you remember from the last slide, x should equal pi over 6, or x could equal 5 pi over 6. Okay? So this was just to show you that we have to do some algebra. I'll do a different question now that will require us to do the whole process. So you might look at this and get a little frustrated and say, wow, that's a lot going on. But in reality, you guys should be prepped to do stuff like this. So 6 cos x minus 3 root 3. The first thing you want to do is try to isolate for cos x. So that would require us to move this entire unit of 3 root 3 to the other side. So one step down, we'll do 6 cos x is equal to 3 root 3. Remember that this is now a positive because it was a negative on one side and we had to move it to the other side. At this point, we must divide both sides by 6, so that way we can get cos x by itself. Divide both of these things by 6 here. 6's will cancel, and we'll have cos x is equal to 3 root 3 over 6. There's a coefficient in front of this root 3, meaning that we can do some math with this 3 and this 6. 3 divided by 6 will be 1/2. So we can reduce both of these down. So it'll be 1 on top, and this will now turn into a 2. So we have cos x is equal to root 3. That 1 is still there, but it's imaginary now. We don't need to write it. Root 3 over 2. So this is something we're a little bit more familiar with, and we can totally find the answer for x here. So we'll go through that process again. Remember step 1, where is cos x equal to a positive root 3 over 2? Well, remember our cast rule that cos is going to be positive in the C and in the A quadrant. So we know our two quadrants here. Look at our special triangles. I know that we have a root 3 and a 2. So I will use the special our root 3 and 2 in it. And I'm asking for the cos. So at what point will cos be a root 3 over 2? Our adjacent angle is going to have to be the root 3, and our hypotenuse is going to be 2. So I'm going to have to use my pi over 6 here again. So pi over 6 is the angle that I'm interested in, and that is going to be my reference. So reference is pi over 6. Step 3 is using our knowledge of the unit circle where things are going to be added or subtracted from pi. So our first answer is reference, then we have pi minus ref, pi plus ref, and 2 pi minus ref. So we've identified already from using our cast rule that we need this quadrant and the fourth quadrant, our bottom quadrant. So let's call this answer I, and this one's going to be answer double I. So for the first one, our answer for x is just our reference, so it's just pi over 6. For the second answer, a little bit more math involved, so it'll be 2 pi minus pi over 6, and that will be 12 pi over 6, making it so that way it's accessible to subtract these things. And it will be 12 pi minus pi over 6 is equal to x, and I need a little more room. This is going to equal 11 pi over 6 equals x. So there is one of our answers, and here is our second answer. Absolutely pause or rewind if you didn't catch anything, but if not, move forward. I'll do a different example using tan. So right now, a couple maneuvers we have to make. We must move that positive 1 to the other side to make that negative. So here, first step into isolating tan is moving the positive 1 over to the other side. That'll give me a negative 1 there. And I'll divide both here by root 3, divide by root 3. So these will cancel out. I will have tan x at this point now is equal to 1 over root 3. And this is negative. So this is something that we're used to, and we're going to be able to find out what x is equal to now. So step 1, of course, is figuring out where things are positive and negative in our cast rule. And we have a negative tan, so tan is going to be negative in this quadrant and this quadrant. And what you'll notice about tan is that if they're negative, they'll be in the S and C, and if they're positive, it'll be in the T and the A. They always go diagonally. So wherever tan is positive, A's and T's, negatives, S's and C's. And you'll notice that over time. Step 2, which special triangle will we have to use to see this? The one with the root 3 in it. So we have our root 3, 2, and 1. And we're talking about tan, which is going to deal with the opposite. So this is the opposite, and this is the adjacent side of things. So if we're talking about opposite of 1, this is where the 1 lies, and it would have to be the opposite angle up in here, and this is the adjacent side here, so we know that this angle up in here is the pi over 6. So unfortunately, all three of my examples so far I've used pi over 6. We will be able to use pi over 3, or even examples from the other triangle, But as of right now, I guess we're going to have to stick with our pi over 6 as a reference, so ref is equal to pi over 6. Step 3, we will lay it out and figure out where our answers will be found. So reference in this quadrant, pi minus reference in this, pi plus reference, and 2 pi minus ref down here. So we know that tan is negative in S and C, so tan will be negative in quadrant 2 and quadrant 4. So answer number 1, let's go with 6 pi over 6. That's just another way to write pi. Minus pi over 6 is equal to 5 pi over 6. That's our first answer. And part 2 will be 12 pi over 6, which is another way to write 2 pi. Minus pi over 6 is equal to 11 pi over 6. So x is equal to these two answers here. And that's it for this tutorial. Like I said, watch this, maybe go back and try a few. Aside from that, just be prepared to learn a little bit more about these during class tomorrow. Thanks for watching, and have a great day.